Hi everyone, happy Friday, and welcome back to another Menlo Community Talk. I'm Mimi, and I'll be your host today. If you're joining us live, come say hi in the chat, and as always, feel free to drop your questions as we go. So, for anyone new here, these calls are our weekly check-in with the team, where we share a bit more context behind our work, all the demos, updates, and experiments from the week. So for today, Frank is joining us with the latest fulfillment and shipping updates. Then, as usual, Yuki is taking us through the latest manual updates, and he also wanted to share some of the more detailed behind the scenes of his work. After that, Ariel is showing some of our recent locomotion policy work, which also means you'll get a first look at the robot doing some pretty cool things. And as always, we'll wrap things up with careers and opportunities across the entire Menlo. Okay, so let's get into it. Frank, over to you.
Yeah, thank you, Mimi. And I'm Frank, and it's nice to meet you all here. And I know it has been a while since my last update about the SMO one, the fulfillment status. But I can tell you, and our SMO one manufacturing is on the track, and we took a little bit more time than expected to improve our mechanical design for better assembly. But now it has been finalized, and our suppliers are working hard to get material ready. And as you can see, our building plan and all of our materials can be ready in the next 2 weeks. And we plan to ship out our first S1 unit by the end of the August. And regarding the second batch, actually, we also kick off the critical material preparation and like the actuator and also computer model. So we also plan to start ship our second batch of SMO and by the end of September. So actually, that's the quick update from me about SMO one fulfillment standards. So just let you know, actually, our supply chain is running full speed to produce the SMO one and can ship this SMO to you as early as possible. Yes, thank you, and then that's my update. And feel free to if you have any question.
Thank you, Frank. I think let's move on to Yuki next.
Hi everyone. Good morning, good afternoon, and good evening, wherever you are. I'm Yuki, and right now I'm working on the manuals and also on the assembly of Asimov 1 essentially. So we figure that we have been talking about origami and the manuals for quite a bit for the last few, I would say, the last few community Fridays, and we realized that we actually never really go into depth about what exactly is origami, how does it work, what is actually the work that we need to be to put into to make sure that we have like the top tier kind of like the assembly and instruction experience that we kind of want to go for Asimov 1. So just a bit of quick update on the manual side first. So this is a preview of what the new manual is going to look like. Not much change in terms of like not much change from the previous version that you guys have seen in Community Fridays in terms of like the contents. But what do change is how we decide to reorganize the manual after getting the feedbacks from team member as well as external partners on how we can make the assembly process much smoother and make the manual much more approachable. So if you guys are familiar with the old manual, it's probably going to be a very long list of tabs of instruction on the left side, but we have decided to kind of like compress them into a much easier way to navigate, right? So we'll just start with an overview, everything that you need to know about Asimov. And we also have moved the design extend reference up top here, so that is easier for everyone to just to get a quick info dump on what Asimov 1 is, and then you can cross-track it with other form factors, or if you want to see if this is suitable for your need, this is a quick way to just check for it. Then we move on to build Asimov 1, which is what we have compressed the part preparation, the assemble, and verification into one big section under build Asimov 1. So inside, it still contain all of the information that you will need it to, progress to the process of assembly and Asimov 1, and then run the firmware, and then finally deploy it, right? So yeah, all of that is still the same. It's just now in much more compact manners, and it's just easier to navigate. And finally, deploy Asimov 1. We are working hard on this section to make sure that like all of the latest content will be inside. So we are currently working on our software stack and preparing for the release. So after that, we'll also update all of the manual to make sure that you can use all of the software that's going to come with Asimov 1 also, right? Yeah. Okay, so that is a quick update on the manual side. So what we want to focus a bit more on this week is actually regarding origami. So we have been talking about origami a lot. Origami is an in-house built tools so that it can help us basically created a 3D visualization of the assembly process, and we can put that in the manual. So how exactly does that work, right? You might ask. So the way it works is actually quite straightforward, I would say. Okay, let's take, for example, for the pelvis module, we go to the sub-assembly A, and then we go to step 1. Right, so this is exactly what you see on the manual as you see on origami, right? You progress to the step, you can see, yeah. So this is a one-to-one matching. So how do we actually put what we have here on origami over to the manuals, right? So the way we're doing that is that inside the manual, inside the manual, there's a components that basically have all the basic functionality of the renderings of the animation of like, well, all of the codes and the software that's needed to render the animation. So we kind of ship that as like a components inside the manuals. So this component will obviously also be made open when the origami is open to the public also. And so when the component is already embedded into the manuals, all we need to do now is actually to tell the components where to fetch all of the parts to render. So the way we do that is quite interesting. So actually, all we does is sending this one, well, like asset file, right, down to the manuals, or like actually is in a bucket, in a CDN bucket somewhere, and it just download down that whole assembly of Asimov 1 actually. So originally this was quite heavy. It exported out from SolidWorks that is like 1.3 gigabyte in size, which we realized that have a lot of impact on the loading time of the manual, as well as like on just general trying to work with the part inside origami, because the mesh count on the asset was very, very high. So it's basically just slow down everything. Yeah. So we will optimize that a bit. We turn it through a Draco compression, and compress the mass by 99.9%. So that reduced 1.3 gigabyte down to only 21 megabyte in total of asset file, which is like a massive leap in terms of performance and loading time and everything. Yeah. So this is the only file that we actually send to the clients when the manual requested for one. What it does is actually is extracted from that one file all of the components and the part, and then separate it out into like a smaller section, right, to be called into to render. So for example, you can see over here on the manual side, if you see this part, right, 216A. Yeah, so it's actually just extracted from this guy over here and just render for that one part only, but focus, and then you can twist and turn it around. Yeah. So that's sort of roughly how it works in terms of like fetching of the asset. So now the question is like, okay, now we know about the asset. How does the animation and so on works, right? So we don't actually shift the whole of like bulk of the code to do the animation for that particular part down to the manual, because you can imagine that's a very, very inefficient process. And that's just bad design in general. If we want to change something to the assembly, if we want to update something, it will get lost with time, right? It cannot be tracked. So what we do instead, actually, the way it works is that in export version, you can actually export the whole manual just JSON. So actually all the step is just a JSON description on like what render part do you use, where is it in space, and where does it move in certain step, right? So for example, over here, if we do, if you see from the starting position, the part 216A is actually above, right? And then the motor is down below. So in the JSON, right, that's the first starting step. Then on the next step, it just update that location, position in space of 216A down toward to the motors. So that's how it works. Yeah. So that's kind of like how we actually do the whole animation. So actually on the front end side, all you receive is just one Asimov, one asset with all the parts, right? And then the JSON file that allow you to do animation. So actually it's very light, and that's how when you kind of like use the manual, it just kind of load instantly on almost all of the steps, even though we have a lot of parts, component, and so on, right? So we did try to put a lot of engineering effort into making not just the animation good, but the experience of using the manual smooth also, because that's very important. That's also mean that if you do load this on your phone, it works surprisingly well, actually. It's very smooth, it doesn't lag your phone, and you can use the whole manual from your phone, which is one of the things that we targeted from the early days when we try to do the manual, right? Because we imagine that if you are working with all of the hardwares and then you don't have like sufficient space, or you just don't want to like have to keep moving around your laptop to see all those steps, having it on the phone will be like a perfect form factors, for example, of Asimov 1. Yeah. So this is like the general understanding of how our origami works and how it's integrated into our manual. All this, like we have said in previous Community Friday, we intend to open origami to the bigger public when we finish with all assembly of Asimov 1, and then like tighten up all the UI, UX, and making sure that it's actually a nice product to use also for yourself. Because eventually what we would really want for the communities and also for ourselves is that this tool will allow all the contributors, if you ever gonna build an extension or change in parts or custom instruction for Asimov 1, you can use this exact tool to build the instruction that you needed, and then like either contribute it to the manual itself, or just release it in your own open source repository as an extension to Asimov 1, right? So we figured that has been like the missing part from the majority of like the hardware open source space right now, in which a lot of times like it's just a release of all the parts, components, and then just some like very vague instruction line on how to put it together, and you are left to your own device to actually figure out how to build the thing that you're trying to get, right? Yeah. So for us, we don't want that. We actually want to have like as much as possible ease people into the building process, right? To actually get the correct final outcome, and you don't have to guess on any of the assembly step. Yeah. So a few other things that we like. Why don't we want to release it now, right? Like, because like I said, there's still a lot of like little nitty-gritty things that I'm still exploring as I use it to build the manual ourselves. So for example, so that like when we kind of export it in like the manual in JSON file, right, is a bunch of text, but we kind of upload all this text into a CDN bucket somewhere so that it can fetch to the manual, and we don't want to bloat the actual like manual code base itself, right? So it's just fetching down. So what does come up during that process is reconciliation. So let's say if you have all the old step, and because we update this quite frequently, there was this like a new set of part, right? So we just did another round update already. So all of the old instruction kind of invalidate itself. But the problem is like the naming of the JSON file instruction, right? So sometimes when we change the number of steps, it doesn't really get reflected right. It need to be reflected in the file's name, right? Because if not, you have like all of the file names just lying on each other, and then you don't know what to call from the bucket. So like now, like after discovering all that stuff, now I have to like a function to like rename the stat file so that like it doesn't collide, and then all that reconciliation in the term of like file levels, right? So yeah, a lot of UI UX improvement also will need to be made. For example, I can show you guys what I'm working on right now, which is the left leg. And what do I mean by that? Okay, so if we go to step 9 of the left leg, so in the left leg section, if we just go to the leg module first, step 9, there's this particular step in which you have to kind of bend the, I think it's here. Yeah, in which you kind of have to bend the knee up so that the motors that you slotted in from the previous step doesn't fall out when you try to secure them. Now, the problem is that what I receive here is just the asset, right? To be able to do a bent leg is really a pain right now, as you can see. So I have to kind of like move all the parts away and like trying to have to rotate this particular part, right, upward somehow like that, right? And then I have all of these components follow alongside with it. But yeah, it's not so very straightforward right now because I haven't figured out how should I do it. Like how should I put a hinge and like selected all of the component and sub-assembly at once so I can just bend it upward, because you see from a base assembly, right, just a straight leg. Yeah. So these are all the kind of things that we need to take into consideration. And like it's only cropped up when you kind of use it yourself, right? Yeah, so a lot of stuff to work on in terms of UIs, UX, and yeah, so on and so forth. Yeah, but I can also talk a bit about the creation process itself, how it's been so far using origami to like create all of these steps. So for example, I can take it here. So one interesting things about origami is that actually all of this placement of the part is done fully by AI. So how does that work? So you have this base assembly, right? And because we have previously written a very, very detailed word instruction on like what parts go where, what belong to what section, the AI sort of just infer all of that and already place the part in the correct position, like you say, like you can see here, right? All of them is already placed in correct position. All the components and like even the actual animation that need to be done. So all this done by AI. So actually it saved like a huge amount of time compared to like I have to like select all the part and do it myself. However, that being said, what it's still not very good at is this problem right here. So while it knows what to explode it out in terms of like the part and components, before like trying to assemble it, right? So like before trying to put it in the correct place. Yeah, but it just doesn't know what the nice and right way to do the animation for that. Yeah. Okay. In any case, that's what we have been working on. This like just a bit on like what's origami, what is like the manuals, like how the manual actually works, and like the work that we need to put into to make sure that all the animation is processed nicely. Yeah, in any case, I hope that it's been informative and interesting. Yeah, well, but thanks guys a lot for all the contribution and all of the feedback I've been receiving so far on the manuals. And if you have more, please drop it inside our Discord or our forums or even in the YouTube comment below. Right. Thank you.
Thanks, Yuki. Yuki's been doing amazing work. You guys should see him agonizing over every detail. So yeah, shout out to Yuki. Next, let's move on to Ariel.
Hello, everyone. Today I will be sharing some update from the recent locomotion experiments and our recent update about the ASIC Lab assets that we just pushed the new URDF. So let me start maybe from this video. And before I starting, I wanted to quick update the previous progress. So we've been using MGLab to train the locomotion policy, and the current state is it can be running quite stable in like lower speed, like less than 0.3 meters per second forward and backwards, but it's not very stable when running in a like higher velocity, such that it has like a tendency to leaning forward, and like it gets accumulated such that like afterward it will get unstable. So we're trying to fix this, and also there are a few issues, including the gates are not there yet because as I introduced before, the training pipeline we're using is with AMP, a research method, such that it not only like include task rewards, but it has like a style reward to tell the robot you need to walk this way. And by how we introduce walking that way, we generated Kimodo humanoid like human walking motions, and we targeted this to Asimov configurations, and then use these motions to give it the reward, such that when it's walking, it has it need to not only satisfy the task reward, meaning like tracking velocities, but it also need to like walk in the very natural gates. But we realized that in the reference motion data, it was not very natural, and sometimes when you generate from Kimodo, it's not like physics aware, so sometimes the feed is not really like parallel to the ground. And to fix this, I actually recorded like the most stable checkpoint and running on the maximum speed with the policy, such that the motion is definitely physics aware because it makes sure that it can run on the simulation, right? And I record that with the maximum speed, such that it has like the most stable gait, and it learns how to like lift up its legs and stuff. And then I reduce down the drawing velocity, and then put this as the reference motion data to retrain the policy. So now you can see it actually lift up its leg much more than before, and this is running on 0.5 meter per second. Still, it has a little bit of tendency of leaning forward, but we're fixing this, and I think the reason for this is mostly because of the gait is not symmetrical, but we already fixed the reference data to make sure that the left leg and the right leg cycle are the same, such that the right leg is not like stopping the right leg motion, which causing the limpness. And also we actually tried to deploy to train the whole policy on Isaac Lab with the same code base, and surprisingly, it actually works zero shot. And this is the Isaac Lab train policy parallel compared with Unitree, and this is running like slow speed here, and you can actually walk on top of the mat, which has a little bit distance to the ground. Yeah, this is the experiment we were running yesterday, and this is like our first trial of training on Isaac Lab, and actually works pretty well. And we also have another video showing the robustness of two robots for handling all the pushes from like all the directions. So Asimov is trained on slightly rough terrain. So there's like 50% of slight rough terrain is called the cobblestone configurations, and like half of the terrain is like flat, such that it learns it has to be very reactive to the pushes. Otherwise, it will not survive on the rough terrain. Yeah, and the side push also works pretty well, which is one of the main thing we were trying to fix. And the issue of the side push is that in reality deployment, we have to push to the maximum for it to react previously. And to fix this, actually there's a pose rewards such that it has to keep its standing pose as the default pose instead of changing too much. And we realized the STD for that is quite strict, so we loosen it a little bit under the push conditions, such that under pushes it knows that I need to loosen a bit of my joint to prioritize more on recovery from the pushes rather than holding the current position. And that's the major fix. And another fix is we check the motor data sheet and adding 20% more of the effort limit to the rated torque. So previously we were very strict on the maximum torque we're using, just setting to rated torque, but it actually can go higher to, but not holding in the peak torque, but we're just adding 20% more, such that it has more torques to cover from the side pushes, and it also help for this situation. And also we are experimenting different policies. For example, we have some guests coming and we wanted to have a policy such that the robot is working, and sometimes you will wave hands to you like this. So this is the training is on top of the locomotion training. I added 3 more dimensions of command as observation. So the first dimension is the wave command, is a 0 or 1 binary command, and if you send it to 0 and hold it constantly, it will just wave constantly. And by default, it's set to 0, and it works the same as the normal locomotion policy. Yeah, so we wanted to train it with the legs such that it awares of the self-collision during locomotion policy. And later we will have a policy with upper body IK such that you can control it with Joy-Con and whatever, and you will trying to follow the end effector by IK solving, and also the lower body is running on whatever velocity command you are sending. Yeah, and our plan for next week is more focusing on optimizing the current locomotion policy, and also we'll try to deploy in real of the whole body control policy we've been trained previously in simulation, such that you can sending a lot of different reference data. It doesn't have to be included in the training data set because the policy was meant to be very robust to every motion, so it will track whatever motions you're sending. So you can just teleoperate it to dance and do squat and do everything, or walking and jump or running, whatever motions you want to do. Yeah, we will give update on that next week. Okay, I think that's all from my side.
Amazing work. Thank you, Ariel. If anybody has any questions, please drop them in the comments or reach out to us over on Discord and forum. But otherwise, I think I'll just take over Herman today and do the intro to our careers. This is my first time doing this, so but we have a lot of openings across different departments, and specifically we're still hiring a lot of roles in the United States. So we are looking for positions from hardware to software to brains. So if you think that you would be a good fit or somebody you know, please apply to us via the link that I'll drop in the chat soon. Otherwise, we also have a wildcard position if you feel like maybe you don't neatly fit into any of these boxes. Yeah, so I'll just drop the link into the chat right now. Please apply, please send to your friends. And with that, I think that's everything from us today. Thanks for hanging out with us and for all the questions in the chat. We really appreciate your time as always. And if we didn't get to your question, feel free to continue the conversation on our Discord and forum, and enjoy the rest of your Friday. And we'll see you next week.